Hello, everyone. I want to welcome you all to my talk today. The title of my talk is Increasing App Confidence Using CI/CD and Infrastructure as Code. And in this talk, I'm going to be discussing some concepts of testing, infrastructure as code, and how you can leverage CI/CD to increase the confidence in your software releases, especially when you're targeting specific deployment environments. So here's a quick agenda of what I'm going to be discussing today. One of the things I want to really discuss is infrastructure as code and how you can leverage that to, provision, maintain, and create the resources that your application releases are going to function on. So before we get into that, let me just take a quick moment to introduce myself. My name is Angel Rivera. I'm a developer advocate for CircleCI. And in my job, I get to speak to the awesome developer community and understand how people are using technology, some of the pain points with those technologies. And I can also offer up any kind of solutions or tips or tricks from my experience, if I have any experience with some of the stuff that we're discussing. The other side of the job is actually bringing some of that knowledge and information that I've learned in my interactions and collaborations back to our team at CircleCI. And I'm providing that information to them so that they could actually build, better, more valuable features for our customers and the developer community. So I want to jump into just speaking about smoke tests and actually just testing in general. As developers, right, and as technology people, we are literally testing our software and our code all the time. We know that there are different variations of testing concepts and testing methods. But what I want to focus in on is smoke testing today. And for folks who are not familiar with like the term smoke testing or don't understand what that is, a smoke test is a test on something, right? Code, could be other things, and I'll get into that in a minute. But let's talk about code in the context of code. A smoke testing is a simple test, right, that reveals any kind of failures or unknowns. And the reason why it's a preliminary test, smoke tests are designed to be limited in scope. So you don't want to be, performing a very comprehensive, long in the tooth, time consuming tests, right? All the time. Where smoke tests come in handy is, if you write some code, you change a little bit of functionality or you add functionality and you already have unit tests, right? You can actually leverage those as smoke tests to kind of suss out anything that's what I like to call low hanging fruit kind of bugs, right? So like, for instance, you've changed some functionality that actually worked before and we would actually pass in certain tests, and maybe you accidentally change some functionality or some syntax that you weren't intending to. If you don't run a smoke test and you deploy that code or promote it to the next stage of your pipeline, of your software development lifecycle pipeline, then hopefully someone will run that test that you didn't run later on down the line, right, in a more comprehensive manner and catch that bug. So again, smoke tests are very lightweight, limited in scope testing that should be occurring anytime some code changes. Now, when I thought about the term smoke tests as a young developer, it brought me back to the time where I was working in the summers as a teenager in construction. For some reason, I always gravitated towards the plumbers and the electricians. I guess their tools were really cool. So I just hung out mainly with them and learned quite a bit of stuff from them during my time as a summer construction worker. But what I actually wanted to kind of relate here was my experience one summer when I was working with a plumber. I watched him, and I actually helped him as well, build out some plumbing for a project or a building that we were working on. And it was pretty extensive, right? We were there for about, I would say 3 days building out this plumbing. and there was a lot of, it was copper plumbing, a lot of fittings. So he was welding, or soldering those fittings together in those joints, which is time consuming, and you have to get that right. But at the end, right, when he finished pretty much soldering all the fittings and all the joints, the next step for the plumber was to test that project, right? And in my mind, I was thinking, oh, wow, he's got to put a hose in there or some sort of water supply, right, to the end of his project there, his plumbing, and then pump water in there. But then I also thought, well, if he has some bad fittings or bad joins, there's going to be an issue, right? There's going to be water leaking all over this place. And at the time, we had equipment everywhere. So I was quite surprised to see that he wasn't going to, test this with water. He was actually pulling out some smoking kind of, I think it was a dry ice machine or some sort. But basically he had a device that produced smoke. And he connected it to the supply of that new project or the new plumbing that we just did. And he literally pumped smoke into the plumbing. And it made sense to me, right? Like, wow, he's actually doing a smoke test, number one. And the other part of it is, so if he's pumping smoke through that whole entire project, the plumbing project that we just completed, he's going to be he's going to be able to easily identify any kind of leaks that are happening or occurring in that plumbing, right, from any kind of joint. So we spent a few minutes just, walking up and down, and inspecting all of the joints and joins that he soldered previously. He was a great plumber, so we didn't have any issues with his work at all. But the next test, right, that he did. So initially he did that smoke test. It was a very light, limited in scope, right, test, and it was almost effortless, which is fine. The next level was he soldered on an air kind of valve to the end of that the plumbing project, and then he pumped air into the pipes, which is a little bit more involved testing. But what he was doing there was doing a pressure test, right, to make sure that if the concept is if you pump enough air and pressure, he also wanted to test the pressure of the pipes to make sure his joints could sustain a certain amount of pressure. Then you had a good connections or fittings were connected properly if it could sustain that pressure test as well. Because you're going to have that when you pump water in there. So he basically, kind of escalated to a new test, which actually was more involved, more extensive. We left that there for about 24 hours. And the gauge on the end, if it would dip down, then obviously we had a leak and we had to figure out where that was coming from. Once he was done with that pressure test and it was successful, he was ready to finally connect the water supply to that new plumbing project and proceed with running water through it. So my point with that story was, again, just showing off, describing the different levels of testing that people go through, not only in software but in the real world. So that smoke test was the beginning of a huge test suite, right, that he was doing. All right, so now that I kind of covered that, let's talk about the failed test, right? So again, if you're running smoke tests on any kind of code that you changed and you encounter a failure, that's a good thing, right? It's a great thing to know right off the bat that there's some issues going on with this code and that needs to be looked at and fixed before it gets released. So with those testing concepts, right, we're just basically looking for the unknowns, and we're trying to avoid them or rectify any problems that will cause issues down the road. And I get this question a lot from folks, which is, when should I run smoke tests? I would say that you should run smoke tests every time your code changes. And what I mean by that is, if you're modifying any kind of existing code or you're adding functionality to existing code, definitely run a smoke test because that will help you kind of identify things such as maybe, things that you or functionality that used to work before you modified it, and now it doesn't work, right? So if you don't do a smoke test, you're never going to know that up front. You just go ahead and push that code thinking that your new functionality, it's working, but the old stuff is working as well. And you just kind of go down that rabbit hole and find out later on through exhaustive testing, hopefully, that, the bug you introduced is caught. So one of the ways that you can ensure your tests are always running is by implementing continuous integration, continuous deployment practices and principles, and leveraging a tool like CircleCI to help with, running your tests using automation. So every time a code change happens in your CI/CD pipeline, that will trigger a build, and within your CI/CD pipeline, and then it'll execute whatever it is that you've defined in that pipeline. You can actually define assign the CI/CD pipeline, a segment of it, to run smoke tests, and that will occur on every CI/CD run, which is what I'm talking about here, right? Is having that confidence that your application has been tested against the testing parameters that you've kind of defined inside of your application in the test suite. So that's well and good what I described, right? That's well and good for like local manual testing, even in your CI/CD pipelines. But what happens when we deploy our software or that release to an environment that we're targeting, right? So what I mean by that is Kubernetes. Let's just use that as an example. If I build an application or change some code in my application, I run it through my CI/CD pipeline, I run my smoke tests. Hey, I even run my more comprehensive test suite, right, against that code, and everything passes. But when it comes to the point of taking that release and deploying it to, let's say, again, Kubernetes, and it fails, right? And it fails every time. Now, I have a problem that I really don't understand what's going on, right? It deployed, it's great, everything's running, but it's not running as intended or as expected. So how would I be able to, right, as a developer or even as an operator, how would I be able to test that? And to be honest, you could leverage smoke testing on those deployments, and you can leverage it by using infrastructure as code. Now, for those of you that are not familiar with infrastructure as code, infrastructure as code is a way or a mechanism for developers, organization, or teams to define compute resources that they need for their applications and their solutions. Now, we're all kind of running, I won't say all, but most companies, teams, organizations are running infrastructure in cloud providers such as DigitalOcean, right? They provide you the ability to not have to stand up your own data center and create resources that will host your applications. DigitalOcean, companies and cloud providers like DigitalOcean make that super, super easy for you. And even though they provide, a reasonable and great, by the way, a great GUI, graphical user interface to manage this stuff, imagine if you had to manage, let's say, tens of thousands of resources from a graphical user interface. That's going to be a huge problem, right? It's going to slow people down. It's also going to increase human error, right? Because we're pointing and clicking inside of a graphical interface. It's not the best experience. And trust me, I have actually had to do that. Not tens of thousands, but hundreds of resources. And yeah, it's very time consuming, slows things down, and it's prone to many, many human errors. So infrastructure as code is the ability to kind of define, maintain, or provision, maintain, and destroy infrastructure using code syntax, right? So a good example is a company called HashiCorp. They produce a product called, an open source product, by the way, called Terraform. And Terraform is kind of the new hotness in infrastructure as code. And it's basically enabling you to define your infrastructure and the resources that you're going to use for your application into files, right? Code files, and using a special syntax called HCL, which is HashiCorp language. You're able to create Kubernetes clusters, compute resource nodes, and required networking type resources within DigitalOcean very easily, right? And it's consistent, repeatable, and ultimately very easily manageable by teams. So, if you have your infrastructure basically laid out in code, you're able to make changes by just changing some values here and there instead of going into a graphical interface and, drilling into a location where these resources are, then hunting down the property for that resource that you want to change. Instead, you can just do a quick search in your infrastructure's code files, right, in that code, and then make the change and then apply it from the command line, which is really, really simple. Anyway, so I went through a long infrastructure as code description, but what I really wanted to talk about infrastructure as code is smoke testing, right? Like, when would you implement smoke testing? Would you implement smoke testing or execute smoke testing in a pre-deployment scenario, like when your CI/CD pipeline is kicking off and running tests on the code that you just changed, or should you just run it once the code is deployed, to like the infrastructure we're talking about, Kubernetes? My answer is always going to be both, right? Like, there's no reason why you can't use CI/CD, the automation in your CI/CD pipelines, to test, at both ends of the pipeline. So what I mean by that is, when you usually start your pipeline, you trigger the first things that people usually do or get the tests out of the way. You can definitely run your smoke tests on your applications there. And then you can also run another set of smoke tests that just test the application post-deployment, right? So you can use your infrastructure as code, create provision a whole new Kubernetes cluster and all the resources it needs, deploy the application, and then have a step in your CI/CD pipeline to then go ahead and test the deployment, making sure that the application is at least coming and responding maybe as you designed or as you expected. But definitely I would say run both. All right. Now, is this overkill? I get that question quite a bit. Like, wow, Angel, I'm testing it on the front end, right? Or the front end of my pipeline, in the beginning of my pipeline, and then you're telling me to test it once it's deployed. And in my mind, the answer is definitely not overkill, because you're changing the state of the app in a sense. And what I mean by that is, you're doing this test in your CI/CD runtime, but you're not actually testing it in the target environment or the target deployment environment, which is Kubernetes. So with all that testing being done, you're definitely expanding the knowledge that you have regarding the behavior of your application in its target environment, if that makes sense. So, again, if you're testing the application in your CI/CD runtime, that's kind of a whole different target environment than it is when you're deploying this application to Kubernetes and then running smoke tests against that. Now, smoke tests can be anything from, am I getting an OK200? Or you can run some smoke tests against, if it's an API service, maybe you can run, a slew of quick smoke tests to ensure that the API is returning proper information, right? The right information, and make sure that that API is also hitting the right resources where it's gathering that information from as well. So before I close here, I just want to do a quick recap on everything, and I'm going to jump into a demo in a minute. But what I talked about today was automating smoke tests, right? Like, make sure that you use that automation in your CI/CD pipeline to run smoke tests. Now, you have to kind of balance that out, because you don't want to run too many comprehensive tests, right? But those smoke tests should cover some of the key elements to your application and the functionality within it, right? Again, if your smoke tests are becoming long in the syntax or voluminous, then I would suggest that you kind of take a look at what's happening within those tests and break them out into smaller, more manageable tests, or limit the scope of that test. So you're not doing comprehensive testing that can then lead into huge kind of time consumption, right? Only run those comprehensive tests when you absolutely need to, and that should be further down in your pipeline. So with smoke tests, right, you're going to be able to catch all those low-hanging fruit kind of bugs, right off the bat. Again, limited in scope, really quick tests. And with that, you're going to gain valuable insights, insights into things that you didn't really, I would say, predict or expect. And again, right, that's what testing is for. It's definitely to suss out any kind of unknown, but it also is a good validator too, right, for your team and your release. And right, it'll increase the app confidence of that release. So your release managers and anyone else, maybe your security team, if you're running some security pipeline tests or security application tests or vulnerability tests, they're all going to be feel a little bit better about a certain release if you've kind of run the application through the ringer, so to speak. And right, the goal here is to deploy the best software consistently. So right now I'm going to jump into a demo and then show you how you can leverage smoke testing, CI/CD, and infrastructure as code. Okay, so now I want to basically demonstrate how you can implement the testing concepts related to smoke testing into your CI/CD pipeline. I also mentioned, right, that you can automate deployments to the target environments where your application will be running. What you're seeing here is the CircleCI configuration file. So CircleCI's platform requires you to define your CI/CD pipelines in a YAML-based file. Start with the CircleCI configuration file. We have the application, right? So what you're looking at is a repository with the application. It's a simple Node.js application. And it's just going to basically host and serve up a static web page with some context or some content in it. And yeah, it'll just basically run some tests against the server, making sure that the application is returning an OK200 response. And then also I have a little script that goes ahead and tests the content of the web page, which you'll see in a moment. So basically, when you start with CircleCI, you have a project sitting in the version control system. In this case, it's GitHub. And what I have here is basically already pushed up, right, some changes. So my code exists. But the first thing I want to show you is this configuration.yaml file. And I have everything kind of collapsed so that it makes sense. And then I was going to just run through it. But basically in CircleCI, you have basically three key elements, which is a pipeline object. You're not going to see that here. It's the overall, right, grouping of this workflow or this, this pipeline. So, or a pipeline is a grouping of all these things. But the two key elements that you need to focus in on during your building of pipelines or defining them in your YAML is the jobs key, which I've highlighted there in line 4, and then if you scroll down to the workflows key, right, in line 149. So those are the really important elements to understand. I'm not going to get into that in this demonstration, but there's plenty of documentation at circleci.com in the docs section. So now that I've kind of shown you, right, the two elements, let's go ahead within our pipeline. We're defining jobs, and these jobs are basically designed to run group commands and run and execute them in that kind of grouping. So let's take a look at like creating the Kubernetes cluster. So right here, right, we have the label Kubernetes creating the DigitalOcean Kubernetes cluster. And then we need an executor, right? So this is basically your runtime. So you need to run your code in a container or on a server or some compute node. At CircleCI, we have 4 different ones. I like to use the Docker executor because it's so much easier than just packaging up things. And then I'm defining an image, which is one of my own kind of custom images that has all my infrastructure as code tools installed on it. The next step, so then once you have your executor defined in your job, right, you create a DO Kubernetes cluster job, you then have this element of steps. So steps are a grouping of commands that you're going to execute. This checkout command is a special command within CircleCI. It's designed to be like an alias for like a git clone or something. So that's what that stands for. So just basically pulling down the latest code for this particular commit. The next step is actually a run command, right? So we're just defining a run command. This is the thing that we want to execute. I've actually used a little bit more of the properties for this, and I'll show you why in the UI later. But you can give it a name so that it shows up really nicely in the graphical interface in CircleCI. And then here's the command, right? So I'm creating a Terraform Cloud credential. And by the way, I'm using an environment variable, which is defined in the CircleCI UI or through the API. What this does is it enables me to use sensitive secrets or data inside pipelines, and it also protects it, right? So I'm just using an environment variable. It's masking the actual values, and then I'm able to commit those environment variables in my file and share them with the team without exposing any secrets. The next step here, right, is another run command, and this time I'm going to go create a Kubernetes cluster on DigitalOcean. I define a few more environment variables, and I'm using CircleCI kind of native environment variables that exist in the system. And then if you jump down, I'm actually CDing or changing directory into the Terraform folders where I have my DO Terraform scripts for creating clusters. And it's no different than any kind of Terraform commands. I do have some environment variables or variables that I use in my Terraform, and I'm just populating them again with some masked values, right, for the system. By the way, these again are at least this DigitalOcean token is secret. So whenever you're using this pipeline, you obviously have to go into DigitalOcean and create a new API token and then leverage that within your scripts. So first I have this application, which is fine. I'm going to change the version number here just to, increment the application, make some changes to demonstrate. We're going to save that. And then we're going to jump into terminal, which will then kind of let us commit this. So let's do a git status, right, to check. We definitely changed the application. So I'm going to do a git commit, and then we're going to say app.js. And we're going to give it a message as usual, right? And then say updated version number. Once we do that, we've committed that locally. Now to trigger CircleCI, we need to do a git push upstream, right? It's going to push this up to GitHub, and then we can jump over to the CircleCI UI. And this is basically the dashboard for CircleCI. As you can see, CircleCI has detected my changes, pushed my changes upstream to GitHub, and kicked off my pipeline. So what we're going to do here is basically show you the pipeline. Let me take this and zoom out a little bit so you can see the whole pipeline, which will probably be a little bit difficult. But what you can see here, right, all of those jobs, those 4 jobs, are actually running simultaneously, as I said earlier. And eventually when all of these pass, this button will be available to me to click. So I'm going to pause right here until all of this is done, and then we'll jump over to the approval process. Great. So now my job has been completed. I can go ahead now and click this button and deploy my application. And then after that, this actual deploy job will kick off. It'll run my smoke test, and then I'll be able to destroy all of that infrastructure. So again, these are all manual steps that I implemented for this demonstration. So let's go ahead and click the button, kick off the next step. And this takes a few minutes. Obviously, we created a new Kubernetes cluster. What's going to happen here is if you click into it, you'll be able to see in a few moments the actual system building out, spinning up the environment and building out a deployment mechanism, as well as for Kubernetes, as well as a service for Kubernetes, which is basically a load balancer on DigitalOcean so that we can access our application on the web. So now our smoke tests have started because our application has been deployed to DigitalOcean. And if you click in here to our smoke test job, basically everything has passed, right? So if you look, the output is here from the smoke test. Tested this IP address, which is the load balancer in the system for the Kubernetes. And then we did our 2 tests, right? It responded with an OK 200. And then the body contains the content that I was looking for based off of my test. Now, if we go back up to our pipeline, I just wanted to show you that this was all created, right? The Kubernetes cluster, which was created in the first tranche of steps in our pipeline. And it was created 11 minutes ago. If you jump into the networking section, which is where we created the load balancer, you can see here, right? Here's the IP address to that load balancer. And then that's where we ran our smoke test against. So yeah, we basically built out a Kubernetes cluster, deployed our application, ran some smoke tests on that specific release. And then if you jump back over to our pipeline, we're at a stopping point again, right? So that we can actually destroy this infrastructure. Now, building things is obviously going to take a little longer, especially with cloud providers. But this is pretty quick. I got to say, working with other cloud providers, building Kubernetes clusters like this from scratch is a little more time consuming on other platforms. This is pretty good. And for a pipeline, you definitely want to have optimizations in place. This is not an optimized pipeline. This is more of a demonstration pipeline. And I just wanted to make that clear. One other thing I wanted to show you was within the Kubernetes, DigitalOcean Kubernetes dashboard, you could actually access the Kubernetes dashboard that's kind of native to Kubernetes. And I wanted to show you the deployments, right? So we created this IACDO project application deployment, and it was created 5 minutes ago using our code. So let's go back and then destroy, right? Destroy this infrastructure. I'm going to click the button, approve. And again, those manual buttons, you can remove those steps once you have a streamlined pipeline and you're not doing a demonstration such as I am. So our pipeline destroy command finished. And as you can see here, it basically kicked off our Terraform destroy commands for the deployment first, right? That would take out the deployment, and then the load balancer that we created. It's kind of in reverse order, and then it takes out the cluster. That way you got to get a clean kind of destruction of all those resources that you made. So if you look at the DigitalOcean Kubernetes section of my account, right? There's no more cluster here. Also, the load balancer has been taken out of commission and destroyed, so that, right, you're not incurring any kind of unnecessary fees or costs. So that's basically the demo for increasing your app confidence using smoke testing and infrastructure as code and CI/CD pipelines. I hope this was useful as a demonstration. And if you want to reach out to me, my Twitter handle is @punkdata. And please feel free to reach out. Thank you so much.